Hello, hello, can you hear me?
Yeah, yeah, I'm sorry, Professor. I got a question. What happened to the chapter 5 classwork assignment? You have posted it, but there were no instructions.
Yeah, because I'll give you the instruction when we see on Tuesday.
Okay, and that chapter 4 assignment, with the empirical rule and the Chevy-Chev's rule, like we give that to you on Tuesday too, right? Since we haven't had
Yes,
classes.
it's on Tuesday, yes.
Okay. And then we were supposed to do, you said, I'm so sorry. You said that we were supposed to only do the videos or the questions that was in the video and then do it 3 more times. You mean the questions that was in the video still, right? Don't make up our own at all.
Yeah, don't make up your own. Just what I say do it 3 times is for you to register. I saw many questions in that empirical rule video. Just choose one of them and then use it to practice. Then use it to now answer the questions and write it on paper and bring it to the class on
O-
Tuesday. Mm.
Okay. What I did is I pretty much just did the whole video.
Oh,
Would that be
that's
okay?
excellent.
Okay,
That's
cool. Thank
excellent.
you.
Yeah. Bring it on Tuesday. Can you hear me? Hello?
Yeah, I'm sorry. Yeah, thank
Oh,
you so much.
oh, no problem. All right, let's begin. This week we're supposed to have start with the probability this week. But on Tuesday I discovered that it was a wellness day, so I had to cancel that Tuesday class because of that. So, which means that we begin today to uh, explore the topic of probability theory. Before we do that, I want to show you the work we did, the area to cover, and then the assignment that are due. Class work 5A, I think I'm going to remove one of them because uh, we didn't, actually, I already did. So I'm going to update this announcement even after we finish the class before we meet on Tuesday. Excuse me. So we started in chapter 4 of the textbook. Of course, you know that you can access the textbook in Pearson by going to the Access Pearson link here and then follow the prompt. Now, test one, I also provided let me show you what I mean by that. I provided the practice text for you for test one. You can see right here, test one review and practice test. So I recommend that you do this one first so that you familiarize yourself with what to expect in test one. After that, you can undo the test one. Okay? Do both of them, I would say. So, and it is due on the 12th, Sunday. So it will cover what we have covered so far in this semester. And I wish you good luck. Now, then we have the homework 5 on probability theory, which should be due on in 2 weeks' time. So you have enough time to work on that. Having said that, I think we are ready to start. Probability. I'm sure you must have heard this word many places or many times, but it is a very important concept in statistics. Simply put, the probability of an event means the likelihood that that event will occur. Or no, no, that is, let me take that back. The likelihood of that event occurring, that is the probability of that event. The way we use it here. Um, I'm seeing them that have not seen. Okay, I see. Okay, she's here. So that what probability is. The likelihood of that event occurring. We use it in education, in business, in gambling, in construction, everywhere. Even a DNA test. That test that says uh, the baby is 99.99% yours. That is probability right there. So now if an event we express this probability with numbers. For example, an event is certain to occur, we give it a probability of 1. For example, the probability of that a coin, that of a coin toss will result in either head or tail is 1. It's either head or tail will show. Now, if the event is impossible, that it cannot happen, we give it a probability of 0. For example, the probability that the coin will land flat without head or tail is 0. So long as it's a fair coin. So long as it's a fair coin. Now, how do we write probability? We write it in this form, either as a fraction, for example, 7 out of 10. I just use 7 as an example. You can use any number you like. Or as a ratio, 7 to 10. Or as a percent, 70%. Or as a decimal. For this class, we'll be using mainly decimal, fraction, and percent. At this point, we are ready to review some of the basic concepts we use when we study the probability of an event. First concept is what we call the probability experiment. A probability experiment simply means those chance process that leads to well-defined results that we call outcomes. For example, when you flip a coin, is a good example of a probability experiment. And the chance process, it can result in outcome. Either a head is showing up or a tail showing up. Okay? Now, how about rolling a dice? The outcome can be is 1 showing, 2 showing. Of course, the dice. I can show you what I mean by dice. It's right here, dice. So you can see. So your experiment. When you buy a lottery ticket, it is equally a probability experiment. Now, let me say this. Many examples we'll be using in this topic we have to do with gambling, because gamblers are the first, I would say, the first people that use probability in a big way. And then after some time, it was realized that this can actually be applied to other field of human endeavor. So now, outcomes. Outcome is a result of a single trial of a probability experiment. So, for example, when a coin is tossed, there are 2 possible outcomes. Either a head showing up or a tail. When you buy a lottery ticket, 2 outcomes. Either you win or you lose. So the outcome is the result of a single trial of a probability experiment. Now, when you take an exam, either you pass or you fail, and so on and so forth. Now, next concept is the what we call the sample space. A sample space is the set of all the possible outcomes of a probability experiment. All the possible outcomes of a probability experiment. For example, if you roll a dice, sample space should be 1 showing up, 2 showing up, 3 showing up, 4, 5, or 6 showing up. These are all the possible outcomes when you roll 1 dice. Now, if it's the days of the week, all the possible outcome becomes Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, no, excuse me, Saturday, or Sunday, and Sunday. Let me put and Sunday. Let me remove all instead. Put and Sunday, and Sunday. Okay, Sunday. Now, for the deck of card, let's see. A card has, I think a deck has 52 cards, I believe. See, 52 cards in a deck of cards. That is the sample space right there. Okay. Now, having said that, we can now go back to where we are. So that's basically what this if you understand this four concept, it will build your ability to understand the concept of probability. Any question in what I have said so far? Any question? Okay, no question. Excellent. Now let's look at another way. A way we can generate the sample space of event using what they call a tree diagram. So it gives us a visual display of the outcomes of a probability experiment. The tree diagram. Look at this. I'm going to use an example with this. Make this layout to be landscape. So let me use this example. It says, look at this example here. It says, find a sample space for the gender of 3 children of a couple. Okay, find a sample space. Let's say that a couple have 3 kids. What will be the gender of those kids? We can find a sample space here. And the one thing this doesn't, it's not tall anymore. I'm going to change it back to where it was. Undo. Okay, I'm going to change it back to portrait. Yeah, that's better. Okay. So you say find a sample space. Here. So let's use boy for B for boy and G for girl. And you say use the tree diagram to find the sample space for a family that have 3 children, to find the gender of those children. And to say what the gender will fall into. That is the result I'll get here. In any family that have 2 children, they must fall into one of these outcomes, So the first child, okay, the first child can be a boy or a girl. So the first child can be, okay, a boy or a girl. Boy or girl. Now, the second child, which you draw from each of the outcomes here, can be boy and girl, boy or girl. Okay. Boy or girl. Well, I think I let me start all over. I think I missed something. Okay, I missed something. Yeah, the first child, you're gonna start from here. So the first child can be a boy or a girl. First child gonna be here. A boy. Okay. Or girl. So the second child can be here a boy or a girl. A boy or a girl. I'm gonna put names here, okay? So I'm gonna move this. Boy or girl. Here we have boy or a girl. Then for the third child, each of these boy, girl, you're gonna assign them boy and girl, okay? Boy or girl. So third child can be a boy or a girl. For each of them, assign a boy or a girl, a boy or a girl, then a boy or a girl. So we have this one, boy or girl. Then girl. Okay. This one, boy. Boy or girl. This one is too close. Boy or girl. Now, then this one will be boy or girl. Boy or girl. And this one is also boy or girl. See? So now, it can be that the family have first child a boy. So first child a boy, second child a boy, and third child a boy. So you can find out three boys. There can be a first child is a boy, second child is a boy, and third child is a girl. Boy, and girl. Okay. And so just follow that that approach. Oh, excuse me, I did something. So you have boy, girl. Have boy, girl. Now it can be that it has a boy, first child, girl, second child, boy, third child. Okay. Boy, girl, boy. Okay. Or it can be that it has a boy, the first child, girl, the second child, and girl, the third child. Boy, girl, girl. So you can follow that same method. It can be that the first child is a girl, second child is a boy, third child is a boy. Girl, boy, boy. Boy, girl, boy. Sorry, girl, boy, girl. Girl, boy, girl. And girl, and boy. Girl, and boy. And of course, all girls can be all girls as well. All girls, GGG. So you have, if we look at, you count them 1, 2, 3, 4, 5, 6, 7, 8. So that the sample space become 8 possible outcomes. Okay? Sample space. Space. For this scenario, becomes 8 possible outcomes. 8 possible outcomes. Any question on this? Any question? So if you see any family that have 3 kids, they must fall within this gender. But either all of them are boys, 3 boys, or 2 boys and a girl. Have a boy and 2 girls, and so on and so forth, or all girls. Now, we can look at this one since there's no question. Say find the probability that the family had 2 girls and a boy. See, find it from based on this sample space. You're asked to find the probability that the family have 2 girls. See, 2 girls and a boy. So for 2 girls and a boy, you have this boy, girl, and boy. So I'm gonna put the outcome right here. The outcome is for 2 girls and 1 boy. Oh, 2 girls and 1 boy. Oh, you're gonna be here. Boy, girl. Okay. BGG, comma, 2 girls and 1 boy. Okay. GGBS. PGG right here. Then we have GBG. GBG. Okay. We say 2 girls and a boy. 2 girls and 1 boy. PGG, GBG, and GGB. These are the outcomes that will give you 2 girls and a boy. So that the probability that the family has 2 girls and a boy will be 3 outcomes out of 8. 3/8. You can get it from the calculator. 3/8. 3 divided by 8 is 0.375. 0.375. 0.375. Or you can call it 37.5%. So this is the probability that the family have two girls and a boy. 2 girls and a boy. Okay. Now, if they want 3 girls, like they asked to find the probability that the family have 3 girls. The outcomes is there's only one outcome that is 3 girls. This one, which is this one, GGG. What's good? Which means that the required probability becomes 1 out of 8 outcomes. So gonna be 1 out of 8. On the calculator, we have change this to 1. 0.125. 0.125. 0.125. Or if you like, you can call it 12.5% chance. So percent actually, in a way, is the probability that I think occur. Any questions on this? Hello, guys. Any question? No question. Excellent. Now, having given you the background, we can now move on to the event. When we say event, we are referring to a set of outcomes of a probability experiment. And there are 2 types. We have the simple events and the compound events. A simple event is an event that has only 1 outcome. For example, if a dice is rolled and there's 6 shoes, then the result is a simple event. But look at it. If you roll this dice now, and only, of course, you know the dice, only 6 shows. There's only 1 outcome. So you can call it a simple event. How about this? If you roll a die and get a 2, again, 1 outcome. It's a simple event. How about getting a Monday when you make a selection? So Monday come out is a simple event, of course. It has only 1 outcome. Now, compound event has more than 2 or more outcomes. Don't put it that way. For example, if you roll a dice and to get an even number means getting 2, 4, and 6. This is more than 1 outcome. So we call it compound events. How about making a selection? You got a weekend. Weekends are, I think, Saturday and then Sunday. Because Friday is a work day, so not a weekend. See, more than 1 outcome. So, see, this one have 1 outcome for simple event. This one has more than 1 outcome. So you call it compound event. Another concept we need to know when it comes to probability is well, has to do with things like impossible event. I've already explained that. When the event is impossible, I mean, cannot occur, it has the probability of 0. If the event is unlikely, that means it has a probability of less than 0.5, which is less than 50%. Then I can say I'm going to remove this. How about if a high school, let me give an unlikely event, for example, a high school kid, yeah, who never attended a physics class, but now he won the International Physics Olympiad. That might be possible, but it's very rare. Not always, not probably, but it depends. Some people do homeschooling now, so there's people that school at home, so it might still be possible. Anyway, but it's unlikely to happen. Now, a likely event has the probability that is greater than 50% or 0.5. Now, at this point, let us explore the approaches we use when we study probability of an event. We're gonna looking at the classical approach, empirical approach, and the subjective approach. Now, the classical approach have to, under that approach, we compute the probability of an event using sample spaces as the sample spaces that we know about the event. So, for example, we already know that a dice has 6 sides, which is the sample space, and we can use that to calculate the probability of an event. We already know that a coin has 2 sides, which is the sample space. We can use it to compute the probability of a head showing up. And for cards, we know that there are 52 cards in a deck, so we can use that to calculate the probabilities. So for the classical approach, we use this formula. The probability of an event E equals number of ways event E occurs divided by the sample space. Now, the one that we call empirical, or otherwise known as relative frequency approach, here we don't know what the sample space is. So we have to observe the occurrence of the event through the experiment and then calculate the relative frequency or the probability using the sample space that we figured out. We have to figure out the sample space, what the sample space would be, and then, use it to calculate the probability per event. Now, the third one, which is this one, we don't use this one much. This one is it's too subjective. And that's how you get the name subjective probability, because it is based on intuition or experience. For example, a doctor may say that on the basis of his diagnosis that there is a 40% chance that a patient will need a surgery, things like that. Not, it's subjective. So we'll focus more on the classical approach and the empirical approach to probability. Let's do some examples here. Say find a sample space following 2 dice. 2 dice. First die has the outcome of the first dice goes from 1, 2, 3, 4, 5, 6. And the outcome on the second dice goes from 1, 2, 3, 4, 5, 6. So if you put it in a chart like this is the second dice, this first dice. So if you throw 2 of them together, it can be that 1 and 1 showing up. That's why you have 1, 1 here. Or 1 and 2. So 1 shows up on the first dice and 2 showed up on the second dice. You have 1, 2. Or that 1 showed up in the first dice and 3 showed in the second dice. That give you 1, 3. Or that 1 showed in the first dice and 4 showed on the second dice. So you continue like that. Like I mean that 2 showed on the first dice and 1 on the first dice. That give you 2, 1. So you got 2, 1, 2, 2, 2, 3, 2, 4, and so on and so forth. So we count all this. Count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So sample space here will be 36 possible outcomes for if you're talking about 2 dice. Okay? But for 1 dice, it's only 6 outcomes. Any question in what I just did? Any question?
No.
Okay, that's good. Let us move on to the next one then. We have it says here, find the sample space for drawing one deck, an ordinary deck, from an ordinary deck. Find the sample space for in a deck of cards. Well, you know that the deck of cards have 4 suits, which are club, diamond, heart, and spade. And each of them is how many number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That each of them have 13 in number. So the club is 13 in number. Diamond is 13. Heart is 13. Spade is 13. So the sample space should be 13 plus 13 plus 13 plus 13. That gives us 3, 9, 12. Get 12. Carry 1 put here. Give us 2, 3, 4, 5. 52 cards. So sample space is 52 cards. 52 cards. So that's, how to get it. So for empirical probabilities. Well, actually, this is classical, not empirical. Classical, because we already know how to the sample space of, the event. Now, let's do some example on classical probability. Okay, maybe one or two. Yeah, let's do one on classical. Let's just do some examples on classical probability. Look at this first one. It says a card is drawn from an ordinary deck of 52 cards. A says, find these probabilities of getting a jack, of getting a 6 of clubs, of getting a 6 or a 3. So, I'll make this to be 18. So let's start with A. A says of getting a jack. We're looking for the probability of getting a jack. Okay. So we have how many jacks? We have, this is jack right here. There are 4 jacks, 1, 2, 3, 4. So that the probability to get the jack is 4 out of 52 cards. 4 divided by 52 from the calculator, we have 4 divided by 52. 0.077 rounded. 0.077. Okay. 0.077. Or if you like, I can call it 7.7% chance. The question says of getting a 6 of clubs. Okay. Of getting P of 6 of club. That's getting a card that is a club that has number 6 on it. So this is a club here. Only one of them have the number 6 on it, this one here. So that the probability of getting a 6 of clubs is 1 out of 52. So you look at the calculator, you have, okay, calculator, change to 1 of 52. Okay. 0.019 rounded. 0.019 rounded. Okay. Now we have this one is of getting a 6 or a 3. So we're looking at part C. The probability of getting a 6 or a 3. This will be the probability of getting a 6 plus the probability of getting a 3. Since you cannot get 6 and 3 at the same time, excuse me. Okay, getting a 6. Let's go. How many 6 do we have? How about this one here? See the 6 right there. 1, 2, 3, 4. And for 3, we have 1, 2, 3, 4 as well. So that the probability of getting a 6 or a 3 is 4 out of 52 for 6 plus 4 out of 52 for 5 for 3. I mean to say. That'll give us 8 over 52, which is the 8 divided by 52. Okay. Times 8. 0.154. 0.154. 0.154. Okay. And that is how to do it. So you find the sample space, find the outcome you're looking for, then divide them. Get your, the event outcome, and then you divide it. Any question on this class? Any query?
No.
Good. Excellent. Now let's look at another example. It says here, 2 dice are rolled. Find the probability of getting A, the sum of 7, B, the sum of 9, C, the same number on both dice, D, the sum of 11. Okay. Now, you already know that for a dice, I just showed you the sample space. It's the sample space for that dice. For 2 dice, I mean to say. And the total possibilities is 36. When you count this, you can get 36. All these outcomes give you 36. So you can now answer this question. It says the sum of 7. Make this seem to be 18. The probability of getting the sum of 7. Let's see the outcomes. The outcomes. Sum of 7. Yeah, let's see the outcome that will give us the sum of 7. See, if I look at this, 6 and 1 give us 7. 5 and 2 give us 7. 4 and 3 give us 7. 3 and 4, 7. So you have the outcomes. 6, 1. 5, 2, and 4, 3, and 3, 4. 5, 2. 4, 3. 3, 4. Then we have 2, 5, and 1, 6. 2, 5. Then 1, 6. All these are the outcome that will give us the sum of 7. So how many of them? 1, 2, 3, 4, 5, 6. So that the probability of getting the sum of 7 equals 6 out of 36. So we can go and put it in there, 6 out of 36. Calculator. 6 divided by 36. 0.167. 0.167. Rounded. 0.167. Or if you like, you can call it, I said that there's 16.7% chance of getting an outcome that's the sum of 7. Any question to that? Yeah, excellent. So let's look at the sum of 9. Sum of 9. Okay. Sum of 9. Let's see how can I give us sum of 9. We have these two outcomes give us sum of 9. 6, 3, 5, 4, 4, 5. So we have 6, 3, 5, 4, 6, 3, 5, 4, 4, 5. See, 6, 3, 5, 4, 4, 5, then 3, 6. Okay. So that there are 4 of them. 1, 2, 3, 4. That means that the probability of getting the sum of 9, okay, will be 4 out of that 6. Okay. So we're going to put it on the calculator. 4, change this to 4. Yeah. 0.111 or 11.1%. 0.111 or like you have 11.1% chance getting the sum of 9. So that answered that question. And next one was the same number on both dice. Let's see the icon that will give us that. Part C. Outcome that shows same number on both dice. Yeah, maybe you can see from here. That's when both dice have the same number: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are the same numbers. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So that there are 6 of them. 1, 2, 3, 4, 5, 6. So that the probability of getting the same number on both dice equals 6. Look at 6. We got it before. We got it, so 6 over 36 was we got the answer as 6 over 36, 0.167. Or if you like, 16.7% chance of doing that. So that is it, how to answer, understand what the sample space is, understand what the event outcome is, then divide. Next one is part D, which says sum of 11. Let's hit outcome that will give us sum of 11. That's part D. Sum of 11. And that give us, okay. This is the outcome that will give us 6, 5, and 5, 6. Only 2 of them will give us sum of 11. 6, 5, and 5, 6. 6, 5, comma, 5, 6. Okay. So that's the probability of getting sum of 11, an outcome that is sum of 11. Okay, equals 2. That's 6. So we go to calculator. So it was 0.055. 0.055 or 5.5% chance of getting small level. So again, this is how we do it. Now let's look at an example that involve something else. Roulette, Russian roulette. See, roulette wheel has 38 slots. If you don't know, look at this. This is how it looks. Roulette. Those of you that go to casino, that's how it looks. The roulette. Excuse me. So it says a roulette wheel has 38 slots. Number 0, 0, 0, 1, 2, 3 to 36. Half of 1 through 36 are red, and the other half are colored black. The remaining number 0 and 0, 0 are colored green. Find the probability that a ball lands on A, a black number, B, a green number, C, a 10, and D, an odd number. So let us use black, B for black, G for green, and then red for R. So it said that it has a 38 slot and number 0, 0, 0, 1, 2, 36. Say half through 36 are red. So half, see, that means this half through 36 doesn't count 0 and 0, 0. So that means half of 36 for it to be. Because the total number of slots is 38. But if you remove this 0 and 0, 0 slots, so half of 1 to 36 says are black, are red, and the other color black. So I'll have that black, half of 36 is 18, I believe. Okay. 18. And of red, sorry, it's black, red equals 18. And the other half, the other two, they are not red. They're not red or black. They are given the number 0 and 0, 0 are colored green. So green, there are two of them. Total, which will give us sample space. Total will give you the 38 slots you have there, which is that total will now become 38 slots. So you get the sample space first. Now, with that, you can now be ready to answer the questions. First question says, it says, what is the probability that the ball falls on the black number? There are 18 black numbers, so that the probability that it falls on black number B will be 18 out of 38. Okay, so you got 18 out of 38. And the calculator will have 18 divided by 38. 0.474, 0.474. Okay, so 0.474, or you have 7.4% chance that it will lie on the black number. For the red number, say a green number. That's why part B say on a green number. Okay, green number. B, that it fall on a green number. Product of green, which is G, equals, there are two greens. So you got 2 out of 38. So I'm going to take it to calculator. 2 over 38. Change to 2. Gives us 0.053. 0.053. Okay. 0.053. Or 53, sorry, mistake. Or 5.3% chance. Let me double check it again. Make sure I have everything. Yep, 0.053. Okay. Now, on a 10, when you look at the slots, see that there's only one number that is 10. Let me look for it. Gotta be somewhere. Let's see right here. There's only one 10. So that the part C says find the probability that it fall on a 10. You start with number 10 on it is 1 out of 38. Excuse me. So you change this to 1. Give me 0.026. 0.026. 0.026 or 2.6. Okay. Then an odd number. Remember I say 1 through 36. Half of it an odd number, so 18. So odd number would be 18. Because odd number like 1, 3, 5, 7, you got 18. Half of it, half of 1 through 36 would be odd, and half of 1 through 36 would be even. So part C says something. Part D says to find the probability that it falls in they find that that it falls in a slot that is an odd number. That one is a bigger one, odd number, which will be 18 odd numbers, 18 slots with odd numbers on them out of 36 slots. Not 38 slots, I mean to say. Which will give us 0.474 or 47.4% chance. So that's solve the equation. Okay. But by now you have the idea of what you can do with probability, mainly on the gambling side. We're gonna do more examples next week. But let me briefly introduce you to the complementary some probability rules, and then look at complementary events, some basic probability rules. I want to take you there. This is the first rule. It says that I call it rule number 1. It says the probability of event A is a number which is either a fraction or a decimal or a percent between and including 0 and 1. So we have this inequality. The probability of event A is less than or equal to 1 or greater than or equal to 0. Okay. Now, this means that the probability of an event can never be a negative value, and it can never be greater than 1. If your answer is 1 point something, then you are wrong, unless it's a percent. Now, rule number 2 says if an event E cannot occur, I've already said it before. If an event E cannot occur, then the probability of that event is 0. Now, rule 3 says if an event is certain to occur, then its probability will be 1, that is 100%. Now, this I can now look at the complement events, and I will take you back to what we have when we have complement. Okay. Now I see, look at this complement event. It says the complement of an event E is the set of outcomes in the sample space that are not included in the outcomes of event A. So I'll call it the opposites. Like now, that the event complement is the opposite of that event. Like if standing up and sitting down are event, then the complement of standing up, the complement of you standing up is you sitting down. That's the opposite. Okay. the complement of you buying a car is you not buying a car. that's so we can look at some of the events, and we use this symbol to represent event complement. Is C. I mean, we can use something different, but this is usually convention. EC. That means E complement. Now, let's look at an example here. Say find the complement of each event. Like this one says selling a letter. Select the letter in the alphabet and getting a vowel. Okay, the complement will be solution. Let's say find the answer. Find the answer for this. Is you're gonna be getting it says select the letter and getting a vowel means not getting a vowel. That means getting a consonant like B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, P, W, X, Y, Z. That's the complement of getting a vowel. And then selecting a month and getting a month that begins with J means getting a month that does not begin with J, like getting March, February, March, April, May, July, August, and so on and so forth. Yeah. So for complements, we have a rules. The probability of event E complement is 1 minus the probability of event A. Or we can say that the probability of event A is also 1 minus the probability of event A complement. Let's see how this works. Okay. It's in a lottery game, each player chooses a 3-digit number between 000 and 999. A player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket loses the game. So losing the game means complement. Find the complement. So we can use W to mean win and lose with W complement. First of all, let's find the probability that the player wins. There are 000 slots to 999 slots. That means there's 1,000 slots there. So the sample space is 1,000. So that the probability that the player wins, which is PW, is he buys the player, according to this equation, he said find the probability that a player buying a single ticket loses the game. So let's find because complement is the opposite. So let's find the chance that he wins, which is gonna be 1 out of 1,000 tickets. Okay. So putting this in a calculator, 1 out of 1,000. 0.001, not even up to 0.1, not even up to 1%. 0.001. Now the complement is that because it says find the probability that the player buying a single ticket loses. So that the probability that he loses, it becomes the opposite of that, which we show mathematically as that he loses. W complement, okay, equals so it's gonna be equals 1 minus the probability that he wins. Okay, which should be 1 minus, excuse me, 0.201. So I'm going to do 1 minus 0.201. It was 0.999. 0.999. Or you can call it 99.99% chance. That's what 99.9% chance that he loses. So they can see why most people buy lottery ticket, they lose, because we have 99.99% against working against you. So any question on this, guys? Hello, guys. Any scholars? Any question?
No.
No question.
All right, guys. Then I will see you guys on Tuesday. Enjoy your weekend.
You too.
And don't forget to do the test. Test 1 is due on this Sunday. Okay.
Is the test open now?
It's open, yeah. If you go to the models, you can see the test right here. It's open.
Do you want us to bring our classwork in on Tuesday?
Yeah, the one we were supposed to bring last Tuesday, but bring it on Tuesday. Not this
Okay.
classwork here. The one is that I put for today. I'm gonna change it to make it to be not due today. Anyway, don't worry about the due date. Once you bring it on the class, I will update it.
Have a good weekend, Professor.
You two guys.
You have a good weekend, Professor.
So when it comes to the classwork 5, we will do classwork 5 in class.
I haven't decided what to do in the class of 5 yet. Let's get the one that I gave you already.
The classwork 4.
When I say watch that video on bring it on Tuesday. Let's take care of that first.
Okay. All right. Thank you. Have a good weekend.
You too. Bye-bye.
Oh, Professor.
Yes, ma'am.
And for classwork 4, I know you said to do it 3 more times for practice. You also want us to hand in the practice for the problem?
Yeah, choose one of the questions and then write it out, just like you did on the first one. Write it out, through the steps, solve it on paper.
Okay.
And bring it to class. I want to see it.
Okay. Okay.
Yeah.
Thank you.
Welcome.